What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're going to continue our work with quadratic inequalities, and we're going to look to see what happens or how can we find where a quadratic is greater or less than a linear equation. Let's get to it. Here we have the example. It says, find the values for x where this quadratic is less than this linear equation. What we found in a previous video is how do we find where these two things intersect? How do we find where it's going to be less than, where the quadratic is going to be less than a linear equation? And what we found was set it equal to 0 and find an equivalent quadratic expression or a quadratic equation to match the intersection of this linear equation and the quadratic. Let's take a visual and see if we can figure out what that means. So this is what this means. We are trying to find where this is going to be, where this quadratic is going to be less than this linear expression. And so we're really looking, where is this going to be happening? And we can do that by finding the intersection of these two functions, these two equations, and then doing a little bit of analysis with a sign diagram to recognize where this quadratic is going to be less than this. Now in the previous video, what we did is we looked to say, well, if we've got this same red and green graph here, superimposed over here, and we rearrange this, let's move these two pieces over to this side of the equation. So I'm going to subtract x and I'm going to subtract 2 from both sides of my equation, and I'm going to be left with x squared. X minus x is 0x, negative 2 minus 2 is minus 4, and I'm going to look to see where that is less than 0. Now this blue function here, this blue quadratic represents this. Where are these things less than 0? Now we could find that algebraically, but visually speaking, that is going to be the same spot. This here is going to be the same spot where this thing crosses the x-axis. Now because these things are kind of at a slant, you're like, no, that's not going to be the case. But look at here. If I draw a straight line here, there's a straight line. It's perpendicular to my x-axis. Look what happens when I move this over here. This is going to line up where that intersection is right here. Where this intersection is right here is lining up exactly where it's crossing, the blue function is crossing the x-axis. And similarly down here, these are all intersecting at the same spot. So if I can rearrange this here and find the values for x where this thing is less than 0, then I can find the whole function where it's less than 0, or where x squared plus x minus 2 is less than x plus 2. So the way I did that before and the way I'm going to do it again is I'm going to just change this momentarily to be equal to 0, and I'm going to solve this. Now I'm going to take out my x squared, and that's going to equal 4, adding 4 to both sides. And so x is going to equal a positive or negative 2. Because I need to consider when I take the square root of both sides, right? I'm taking the square root of both sides. When I do that, I'm considering the positive and negative result of that square root. Because I don't know what x is. X could be 2 or x could be negative 2. 2 times 2 is 4. Negative 2 times negative 2 is 4. So either one of these, positive or negative 2, could give me this result. So I know now that this spot here and this spot here is going to be negative 2 right there, and this here is going to be positive 2. Or similarly, here x equals positive 2, here x equals negative 2. And now, using the sign diagram from the previous video, we don't have to do it because we actually have graphs here, but let's just use it for consistency's sake. These are my x values where I know this thing equals 0, where this function equals 0. So it's going to equal 0 at positive and negative 2. I want to know where is this thing going to be negative. Now, of course, we can see it's going to be negative between these two values. But if I chose any value between those values, I could choose 0. I could choose negative 1. I could choose positive 1. I could choose negative 1/2. I could choose anything I wanted between negative 2 and 2. And the result will be, when I drop it in here, I'm going to get a result less than 0. So for example, if I took negative 1/2 and I squared it, that's going to give me a positive 1/4. a positive 1/4 minus 4, I've got a lot more negatives here than I do for my 1/4. That's going to end up with a negative value. If I put 0 in here, if I put 0 in here, 0 squared minus 4, that's going to give me a negative value. All of these things are going to give me a negative value when I put it back into my function or into my equation. Right? The y values are going to be a negative value. Similarly, if I take values greater than 2 or less than negative 2, let's just say 10 or negative 100. When I drop those into my function, I'm going to see that I'm going to actually have values greater than 0. So 10 squared minus 4. Well, yeah, that's going to be 96. So that's going to give me a positive value. If I do negative 100 and I drop that in here, I'm going to get negative 100 squared. Negative 100 times negative 100 is positive 1,000. Positive 1,000? Positive 10,000. Positive 10,000. 10,000 minus 4 is still going to give me a very big number. There's my positive value there. So as we can see here, where this thing is less than, where this function is less than x plus 2, or where this function is less than 0, are all going to be the same values, which are right here between where x is greater than negative 2 and x is less than positive 2. Those are my values where this function is going to be less than this or less than this. These sign diagrams will come back again when you're working with calculus and you're finding the first derivatives and second derivatives. So stick this in your pocket, hold on to it, use it here, even if it's kind of intuitive on where the inequalities might be. You might not necessarily need to use it as much here, but they will definitely come in handy when you get to calculus. I hope this was helpful. If it was, give me a like the video, spread the word to the YouTube algorithm, and I'll see you in the next video.